Hello, welcome to day 2 of distance learning. Today we're going to find the determinant of a matrix. And we will get more to why a determinant is helpful or what is the purpose of this as we use it. Okay, the determinant of a 2x2 matrix is given by AD minus BC. Okay. Now, the notation, you can write it as a determinant of A, or you can write it as A inside of these straight lines. You can write the actual matrix inside of straight lines, and that means take the determinant of this matrix. Okay, so the determinant of 6, -3, 2, 3, the determinant of A, is equal to 6 times 3, so AD minus BC 2 times -3, 18 plus 6, and that would be 24. So the determinant of A is 24. What did we just find? We'll get to it later. Finding the determinant of a larger matrix involves finding the minor and finding the cofactor. These are interesting new vocab words, and so we will practice finding them. The minor IJ, so it's associated with a particular row column. So they want us to find the minor 1, 2. So first row, second column. What we're going to do is we're going to actually delete the first row and the second column. This is in order to find the minor for row 1, column 2. Okay. The minor is the determinant of the matrix obtained after the deletion. So, the determinant of, you have 0, 4, -2, and 6. Those are the things that are not being crossed off. So, 0, 4, -2, and 6, this is our little matrix that we need to find the determinant of. The determinant of a 2x2 matrix we just did in the last slide, so 0 times 6 minus -2 times 4. That would be 0 plus 8. Okay, so 8 is the minor for row 1, column 2. But we still haven't found the cofactor. Okay, so the cofactor, A sub 1, 2, okay, based off of this minor, is -1 to the, take I, which is 1, take J, which is 2, and add them, multiplied by, that is an interesting looking M, multiplied by the minor. Okay, so the cofactor is -1 to the third power times the minor. -1 to the third power is -1, and the minor is 8, so our cofactor is -8. Again, you're probably still wondering what exactly we're finding here, but bear with me. Okay. Now, do you want to have to plug this in each time you do it? No, you don't want to have to do that. So you can actually take a look at your, to get the sign for the cofactor, okay, whether it's -1 to a positive exponent or whether it's -1 to, an even exponent, or whether it's -1 to an odd exponent, so that you know to keep or change the sign of your minor. You can actually follow these signs. So we have, if this is our first row, first column, you have negative 1 to the first row plus first column. If this is our first row, second column, we have negative 1 to the 1 plus 2, negative 1 to the 1 plus 3. Continue on. Negative 1, this is the second row, 2 plus first column. Negative 1 to the second row, second column. Negative 1 to the second row, third column. And so on. We end up getting the signs. Negative 1 to the 2 is a positive. Negative 1 to the 3 is a negative. Negative 1 to the 4 is a positive. And as you continue, it will be every other. And so most people choose to memorize the signs for the cofactor rather than actually plugging in this negative 1 to the something plus something. They just kind of remember the picture. Okay, so to actually find the determinant of a square matrix, it's obtained by multiplying each element of the first row by its cofactor and then adding the result. Okay, each element in the first row by its cofactor and then adding the result. Let's see what that actually looks like. Okay, so we're going to expand upon the first row. That means that each element in the first row is going to be multiplied by its minor. Okay, so 2, here are the numbers in the first row, 2, 3, and negative 1. Okay, the minor of 2 happens when we delete those 2, so you should have 2, 4, 5, 6. The minor for 3 happens when you cross off these, and you should get 0 for the determinant of these 4 numbers. And then the minor for negative 1 is 0 to negative 2, 5. So remember the cofactor, the signs for the cofactors matrix that we had before. We're going to actually assign these signs to our numbers here. So the sign that's going to go in front of 2 is going to be a positive. And I'm going to write that in even though it doesn't need to be written in. The sign for 3 is going to be a negative. That one does need to be written in. And then the sign for negative 1 should be a positive. Positive, whatever it is. And so it's already a negative, so I'm just going to put plus a negative, even though that's not necessary, just so you can see how those signs play a part. Okay, so it's going to be 2 times 6 is 12 minus 20 minus 3 times 0 times 6 minus negative 8. And then we have negative 1 times 0 times 5 minus negative 4. Continue on, and you get negative 44 is the determinant. Woo! Did you know that you can actually use any row or any column to find its minor and cofactors, and it will give you the same result? Okay, let's do it again. So here we have the same matrix as before, same exact matrix, except we're going to expand instead of expand on the first row, which is what we did before, we're going to expand on the second row, by the second row, and expand by the third column. Let's see how that goes. All right, our second row, and by the third column. Okay, so this determinant should be 0, 2, and 4. Those are going to be multiplied by their minors. And the signs that we should give them, okay, let's go here. We have the second row is minus plus minus. So I'm going to put those signs in. Minus, plus, minus. Okay, so when we delete the first column, second row, we get 3, -1, 5, 6. Continuing on. When we delete the second column, we get 2, -1, -2, 6. Still learning how to do this. And we're going to delete the third column, and we end up getting 2, 3, -2, 5. Okay, so this right here should give us -44. Let's see. Yay! 0 times anything is 0, so we have 0 plus 2 times 12 minus +2 minus 4 times 10 minus a -6. All right. That is 2 times 10. 4 times 16. 20 minus 64. Is that -44? Yay! Okay, let's expand along a column. Expand along a column, you say? What? Okay, so these are my coefficients. I guess they're not called coefficients, but these are going to be multiplied by their minors. So you have -1, 4, and 6. Okay, then I'm going to check their signs on our cofactor, the signs for the cofactor matrix. Okay, that's plus, minus, plus. So this is plus, minus, plus. And we're going to multiply these numbers by the determinant of the 2 by 2 matrix after deleting the row and column that they're in. This is 0, 2, -2, 5. 2, 3, -2, 5. 2, 3, 0, 2. Sorry, that should be a straight line, not a bracket. Okay. And to save you some time watching me do mental math, there we go. Again, we get -44. All right, this is our last example, the invertibility criterion. So why would finding the determinant ever be helpful for us? Well, if the determinant is equal to 0, then we don't have to go through the hassle of trying to figure out if a matrix has an inverse, okay? And maybe that's not much of a hassle for a 2 by 2, but once you get into something like a 4 by 4, like we have here, yeah, that's kind of a big pain to do all those row operations. So let's find its determinant to show that it has no inverse. Ooh, I'm guessing the determinant is going to be 0. Now remember, you can expand on any row or any column. So I'm going to expand upon the second row. My second choice would have been to expand upon the third column because there's a lot of zeros in there. That's going to save me time. You've got 0, 0, 0, 3. Oh, whatever these equal is just going to be 0. So you just have 3 times a matrix, the determinant of a matrix. Oh, and it's a big one. It's a 3 by 3 this time. So we delete this row, we delete 3, the column with 3 in it, and we have 1 2 0 5 6 2 2 4 0. And then we check, okay, this is technically the second row 4th position. So what sign should I have on this cofactor? Well, a to the 2 4 means I'm going to multiply -1 to the 2 plus 4. Okay, that's to an even number, that's a positive. So this does not change. This is still a positive 3 times the determinant of this 3 by 3. Okay, I can actually expand this matrix, I can expand to find the determinant of this matrix. And I'm going to expand upon the 3rd column because it's got a lot of zeros in it. I'm going to do that off to the side so we don't get too confused on what's exactly happening. Okay, the determinant of there's some more zeros. That makes my life easier. So really, it's just the 2 that's going to be multiplied by the determinant of 1 2 2 4. Okay, so the determinant of this thing that we found, I guess we could give it a name, is equivalent to 2 times the determinant of this smaller thing, which is much easier to do. So we will call this matrix C. So if we multiply 3 by the determinant of matrix C, we would get our answer. Now we're going to do that. 3 times the determinant, guess what? This right here is equivalent to the determinant of matrix C. So 2 times, you know what I just realized? We forgot our cofactor, the sign for our cofactor. Okay, the sign of the 2, since it's in the 2nd row 3rd column, the sign of our 2 should be a minus. Okay, that's what we're going to be putting in here. So 3 times -2 times the determinant of this. And we're going to go ahead and simplify. You can multiply these 2 right here. So -6 times the determinant. 1 times 4 is 4 minus 4. -6 times 0 is 0. Wait, is that what we were supposed to get? Yes. Show that A has no inverse. If the determinant of A is 0, then it has no inverse. We just showed the determinant of A is 0. Therefore, these 3 little dots mean therefore. Therefore, A has no inverse. And that's your lesson for today.